There are four types of integration. All right, and we know integration is just the reverse process of differentiation. The four types of integration that you'll come across in CAPE Mathematics for Unit 2 is integration by recognition. So these are functions that you're able to just look at and know the integral of. For example, when we differentiate sine, we get cosine. So if you get the integration of cos, you know that the integration of cos is sine. That's integration by recognition. There's also integration by partial fraction. That's when you get fractions to integrate and you can separate them into the sum of two partial fractions and integrate. Then you have integration by substitution. This one's a little more tedious. You have to recognize what to substitute in order for the integration to work out. Then there's integration by parts. All right. Now, looking at integration by recognition, these are functions that you should be able to integrate easily or recognize them easily. So for example, to integrate x to the n, when we integrate x to the n, it's x to the n plus 1 over n plus 1 plus a constant c. We just add 1 to the power and divide by the power. Integrating this function, add 1 to the power, divide by the power. Integrating 1 over x is ln the modulus of x. Integrating 1 over ax plus b. Well, what you have to realize is that the differential of the denominator needs to be in the numerator for it to be ln. So what we do is multiply it by a over a, and so we get 1 over a ln the modulus of ax plus b. Integrating exponential power, we just divide by the differential of what's in the power. So we integrate e to the x to get e to the x. We differentiate e to the ax plus b, and we know the derivative is a, so it's going to be the integral of e to the ax plus b. We just divide e to the ax plus b by a. We integrate sine, we get minus cos, and that's because when we differentiate cos, we get sine. We integrate cos, we get sine. We integrate the tan of a function. When you're integrating tan, you're integrating sine over cos. And the differential of cos is minus sine. And so when we integrate tan, we get minus ln cos x, or we get ln sec x. We integrate sec, we get, all right? So very easy to integrate these functions. All right, this one is incorrect right here. That says integral of sec. All right, this one is incorrect right here. When we integrate sec square, we get tan. All right, so these are functions that you should be able to recognize. These are just some general ones that you should be able to recognize and integrate. So let's look at some examples. So looking at these examples now, it says integrate e to the 5x minus 2. Now the derivative of e to the 5x minus 2, that is 5. So when we integrate this function, it's just going to be e raised to, right back here, 5x minus 2. And then of course, you're going to divide it by the differential of what's inside the power, which is 5. And since it's an indefinite integral, you just put plus your constant of integration. Very easy. Easy question. Now, this one now, you're integrating cos. When you differentiate sine, you get cos. So when you integrate cos, you get sine. So when you integrate cos, you get the sine of, now, when you get the sine, it's the sine of all of this, which is 3x minus your pi by 2. But then, of course, after you minus your pi by 2, all of this is going to be divided by the derivative of what's inside this bracket, which is 3. So it's being, all of it is being divided by 3. plus your constant of integration. So you write here plus C. Now this one is a little bit different now. You're asked to integrate 2 raised to the 7th power of x. Now, a lot of persons might find this difficult to integrate 2 to the 7x. All right, a lot of persons actually find that difficult to recognize. And I didn't put it in the recognition formula, how to integrate a to the x. So I'm going to show right here how you integrate a to the x. I'm just making the general formula. All right. Now, let's say you were asked to find that question. Let's say you were asked to find the derivative of, let's say I ask you to find the derivative of 2 to the 7x. How do you differentiate 2 to the 7x? To differentiate 2 to the 7x, what you would actually get is, this is equal to the derivative of 2 to the 7x is, now differentiating 2 to the 7x, you can think of this as 2 to the x raised to the 7th power. So it's bring down the power 7, subtract 1 from the power to give 2 to the x raised to the 6th power times the differential inside the bracket, and the differential inside the bracket is 2 to the x ln x. So that's how you differentiate 2 to the 7x. 2 to the x ln 2 rather, 2 to the x ln 2. All right. Now, 2 to the x times this 2 to the x raised to the 6th power is just 2 to the 7x. So all in all, this works out to be 2 to the 7x. 2 to the 7x. Now pay attention. This is 2 to the 7x because 2 to the x raised to the 6th power times 2 to the x is 2 to the 7x. All right. And you're wondering, where did I get this from? All I did was just rewrite 2 to the 7x. For those that will not follow yet, 2 to the 7x is the same as 2 to the x raised to the 7th power. All right, just for clarity, 2 to the 7x is the same as 2 to the x to the 7th power. So to differentiate it is carry down the power 7, subtract 1 from the power, leave 6 times the derivative of 2 to the x. And the derivative of 2 to the x is 2 to the x times ln 2. Now, 2 to the x to the 6 times 2 to the x is 2 to the x to the 7, which is 2 to the 7x. And then we can bring up the power to write 2 to the 7x times ln 2 to the 7th power. ln 2 to the 7th power. All right, and so that's the derivative of 2 to the x. Now, why did I do all of this before I integrate? You may wonder, why did I do all of this before I integrate? Well, I'm going to show you why. Now, what if you were to divide both sides now? Or let's say you were to integrate now. So let's say I ask you to integrate d by dx. I'm asking you to integrate d by dx of 2 to the 7x. Integrating d by dx of 2 to the 7x. And that's equal to, now we're integrating both sides now here, and that would be equal to the integral of 2 to the 7x ln 2 to the 7th, 2 to the 7x ln 2 to the 7th. Now never leave off your dx. I left off the dx here. 2 to the 7th is what, 128? I'm not sure, so I'll just write back 2 to the 7th. All right. So if you want to know what the integral of 2 to the 7x is, now integration and differentiation are reverse process of each other. So integrating the derivative is cancel each other. So if we were to divide now both sides by ln 7, 2 to the 7, what we get is that 2 to the 7x, and divide both sides by ln 2 to the 7, ln 2 to the 7th. And so what we're getting is that the integral of 2 to the 7x is equal to 2 to the 7x over ln 2 to the 7. All right? And that's how you integrate 2 to the 7x. The integral of 2 to the 7x is equal to 2 to the 7x over ln 2 to the 7. And just add plus your constant of integration. All right? So that's how you integrate 2 to the 7x. You have to find its derivative first, and then it's easier to observe and realize what's its integral. But it's still integration by recognition. Right here, we found that the integral of this, so the integral of 2 to the 7x is just 2 to the 7x over ln 2 to the 7th. Plus some constant of integration. So I'll just write plus c. Very easy. Soft. Now how do you integrate tan? When you differentiate tan, you get sec squared. But when you integrate tan, what do you get? When you integrate tan, you get ln sec. When you integrate tan, you get ln sec. So that's recognizing that we get ln sec. When you integrate tan, we get ln sec of. Now we just put back our 5x plus pi by 2. ln sec 5x plus pi by 2. And all of this is going to be divided by ln sec 5x plus 2, and all of it is divided by our derivative of what's in the bracket, which is 5. So it's ln sec 5x plus pi by 2 divided by 5 plus some constant of integration. Very easy. Some more question. Let's say they're asking you to find the integral of 5 to the x. This is again integration by recognition. Integral of 5 to the x is just equal to 5 to the x divided by, so it's 5 to the x divided by ln 5, and this is going from 0 to 1. From 0 to 1, because this is now a definite integral. So what that means is we plug in 1, and so the answer is 5 over ln 5. 5 over ln 5 minus, plug in 0, we get 5 to the 0 over ln 5, and that's the answer. 5 to the 0 over ln 5. So if you want, you can simplify this in terms of decimal. 5 over ln 5 minus 1 over ln 5. So as a decimal, I am getting 5 minus 2 point something. So you can simplify this if you want. Now this question right here asks us to integrate 3 over 7x minus 2. Now integrating 3 over 7x minus 2, this is now integration by substitution. So this first one was still recognition, but this one is substitution. Now, what am I substituting? I'm going to call the denominator u. If I call the denominator u, let's call the denominator u, 7x minus 2, right? Let's call the denominator u. Then du is going to be equal to the derivative of 7x, which is 7. So du is equal to 7 dx. That's du. Du dx is 7. So if I multiply up the dx, I get du is 7 dx. So what I need is 7 dx in the numerator So how can I get 7 in the numerator? Well, to get 7 in the numerator, all I need to do is multiply by 7 over 7. If I multiply by 7 over 7, right? I multiply by 7 over 7. I'm going to get, then I can factor out the 3, and factor out a 7, and I get 3 over 7 times the integral of 7 over 7x minus 2. Aha, easy. So I get 7 over 7x minus 2, right? That's what I'm getting when I multiply by 7 over 7 dx. Now this 7x minus 2 is u, and this 7 dx is du. And so this becomes equal to the integral of 1 over u du. So that's what it means by substitution. So when you do substitution method, it leads back to recognition. And then we know that 1 over u du, when you're integrating this, is just ln u. So the final answer is just ln the modulus of u. But then what was u? 7x minus 2. Oh, and I forgot the 3 over 7 right here. So I'm put on the 3 over 7. And the 3 over 7 should be here as well. 3 over 7. And so 3 over 7 ln u. And so that just becomes 3 over 7 ln, and you put back what u was. U looks like 7x minus 2. So again, you just write back 7x minus 2 plus some constant of integration, which is your plus c. Very easy question, and that's how you do substitution. So substitution leads back to integration by recognition. Now let's look at the next one right here. So we have 6x squared e to the 3x. You might be saying, whoa, how do you know how to identify what to substitute? Now I'm going to say, well, if I had called this u, look at this right here. If I had called this u, then what's going to be my du? Oh, this should have been a cube. I'm going to put the cube right here. A cube should have been on this question. We're looking at substitution. If I call it e to the 3x cube u, yeah, there should have been a 3 right there. If I call u e to the 3x cube, so that's my u. If I call e to the 3x cube u, then my du is going to be not e to the 3x, you're calling u. Apologies, you're calling u 3x cube. Sorry, u is 3x cube. So if you call u 3x cube, then du is going to be bring down the power and subtract 1 from the power. So u is 3x cube, and du is just 9x squared. 9x squared. But look, we have 6x squared. We don't have 9x. So again, how are we going to get this to be 9x squared? All we need to do is multiply by 9 over 9. We can always multiply by 9 over 9. So multiplying this by 9 over 9, if we multiply this by 9 over 9, so I'm going to bring an arrow out here to say this will be equal to, if I multiply this by 9 over 9, right, I'm multiplying it by 9 over 9. If I times it by 9 over 9, I can factor out the 6 to put 6 over 9 times the integral of 9x squared e to the 3x cube. E to the 3x cube. Now right here, so now pre this. Now look why it's the same thing. If 9 cancels a 9, so this is still 6x squared e to the 3x cubed. Then we're going to substitute our u. Our u is 3x cubed and our du is the 9x squared dx. So if we're substituting, what we're getting is 6 over 9 times the integral of, this becomes e to the u, and this part becomes du. So it becomes 6 over 9 e to the u du. Then when you integrate e to the u, you just get back e to the u. So this answer works out to be 6 over 9 is really 2 over 3. So it's 2 over 3 e to the u, 2 over 3 e to the u plus some constant c. But then what was u? U was 3x cubed. So finally, you're just going to say this is 2 over 3 e to the 3x cubed, e to the 3x cubed plus c. So again, integration by substitution leads back to integration by recognition. Let's say that one more time. Integration by substitution leads back to integrating by recognition. Let's look at this other example now of substituting. Again, how do you know what to substitute? So I'm seeing 1 over root x e to the root x. And you're going to say, what do I substitute as u? So what I'm thinking is let root x be u, and let's see what comes out of it. If u is equal to root x remember is x to the half power. Always remember that root of x is x to the half power. Root of x is x to the half power. Many people forgot that from Sir's logs and indices. So that's x to the half power. Then what would be du? Then du would simply just be, when I differentiate x to the half, it's a half x to the minus half. It's a half x to the minus half. Now what is x to the minus half? 1 over x to the half. And so I can always rewrite this as 1 over 2 times the root of x, right? 1 over 2 times the root of x. So clearly, what we're needing in the denominator is a 2. We need a 2 here, so don't it? So since we need a 2 in the denominator, I'm going to multiply the numerator and the denominator by 2. Right? So bringing an arrow out here to continue this question, it becomes equal to, we're going to keep the 2 in the numerator, so we're going to write 2 times, we're going to bring this 2 inside the integral to get 2 times the integral of 1 over 2 root x. You're wondering, why did I bring in this 2? I bring in this 2 to generate my du. It's 1 over 2 root x times e to the root x. Now root x, which is x to the half, is u, and 1 over 2 root x is du. So this becomes equal to 2 times the integral of, now this becomes e to the u, and this is du. So integrating e to the u du. Then now integrate e to the u, we just get back e to the u. So it becomes 2 times e to the u plus your constant of integration, which is your plus c. But then what was u? U was root x. So the final answer is 2 times e to the root x plus your constant of integration plus c. And this is very easy. So that is integration by substitution. Again, integration by substitution leads back to integration by recognition. The hardest part is to identify what is your u. In determining what is your u, you're looking to see where you can generate your du from in the question. So, for example, I noticed that if I had u as root x, then I could generate my du with something with 1 over root x. So that's why I did not make u be 1 over root x. All right. Now I know that 3x cubed, when I differentiate 3x cubed, I get something with x squared. And so that's why I let the u be 3x cubed. All right. And so that is how you pretty much know which one to be your u, so that you can easily substitute that for your u. And that's integration by substitution. Oh, and here's one more. This is one last one. One more integration by substitution. So let's call this part. Now, what I know is that when I differentiate 6x squared, I get 12x. And so I'm going to call this my u. So I call my u in the denominator 6x squared plus 8. That's what I'm going to call my u. Now when I differentiate 6x squared plus 8, I will get my du. I will get du, and du is just going to be 12x. du is 12x dx. So what I notice is that I need a 12x up here. So what I'm going to do is I'm going to multiply this integral by 12 over 12. Multiplying this by 12 over 12, I don't change anything. But then I can bring the 12 on the inside to get that this is equal to 12. Now we're bringing in the 12. And so this is now equal to 1 over 12 times the integral of 12, bringing this 12 to get 12x over the square root of 6x squared plus 8 over the square root of 6x squared plus 8. All right, so that's what I get. Good, good, good. Now that I get this, what's my next objective? My next objective is to substitute u and du. So this works out now to be 1 over 12 times the integral of, now my u is 6x squared plus 8, and my du is 12x dx. So that part works out to be, this part right here is my du, that's du. So it's 1 du over the square root of u. Now you might ask, how do I integrate 1 over root u? You're saying, whoa, that's crazy. No, it's not. It's very easy. And so this is really just 1 over 12 times the integral of, now the root of u, this is really 1 over u to the half, and so this is u to the minus half. That's u to the minus half. All right, so that's what you would get. Then you can integrate this easy. To integrate that now, you add 1 to the power, then you divide by the power. So adding 1 to the power becomes u to the half, and then you divide by the power of half. So u to the half divided by half plus your constant of integration, c. So now you're going to work out, simplify this, which is 1 over 12 times 1 over half. That's 1 over 24. 1 over 24, 1 over 12 multiplied by 1 divided by a half. So that's 1 over 6. So it's 1 over 6 times u to the half. But remember, what is u to the, u is 6x squared plus 8. So now, again, guys, 1 over 12 multiplied by 1 over a half is the same as 1 over 12 times 2. So you're getting 1 over 6 u to the half power, and u to the half power is the square root of u. plus c. But again, what is u? U is 6x squared plus 8. So the final answer is 1 over 6 times the square root of 6x squared plus 8. And this is again integration by substitution. All right, so integration by substitution leads to integration by recognition. So that's the aim of substituting, to go from integration of substituting to where you're just recognizing. All right, easy. Now this one now is a actual question where it says, prove that this thing right here equals the 98 over 3. So to show them that it equals 98 over 3, what you're going to do is you're going to again identify your u to generate your du. I know that if I call u x squared plus 9, look what's going to happen. If I call u x squared plus 9, if I call u x squared plus 9, then what is du? Then du is going to be 2x dx. Du is going to be 2x dx. That's my du. But right here, so now this question only have x right here. So in order to get 2x dx, I'm going to have to multiply this by 2 over 2. So I'm going to put a 2 right here and put a half on the outside. That's 2 over 2. All right, so what I'm doing is generating my u. I generate my u and my du. Now the next thing is now to write down your upper and lower limit. Your upper limit is going to be equal to, when x is 4, you're you plug in 4 square. 4 square is 16. 16 plus 9 is 27. All right, because we're integrating with respect to u. And your lower limit is going to be when we plug in x as 0. Plug in x as 0, we get 9. And so the question up here is going to then become, we're actually finding now a half, the integral of, we're going from the lower limit of 9 to 27, 9 to 27 of, now this 2x dx becomes your du. And so what we're integrating is the square root of u du. That's all we're integrating now. So the square root of u du is, this is really u to the half power. So when we integrate u to the half power, it's going to become a half of, put in your integration bracket now, integrating u to the half becomes add 1 to the power to become u to the half, divide by the power of a half. And we're integrating, of course, from 9 to 27. From 9 to 27. Now, I don't like to work with so much fractions. So 1 being divided by a half, 1 divided by a half is really 2 in the numerator, and 2 over 2. 2 over 2 is really 1. So all of this question is really working out to be u to the half power. This is really working out to be u to the half, going from 9 to 27. Going from 9 to 27. So let's see what we are getting now. We should get 98 over 3. So when we plug in 27, we're getting the square root. We're getting the square root of 27 minus, this is u to the half. Oh, my apologies. Right here, mistake is made. When I integrate, this is u to the half. When I integrate, a half plus 1 is 3 over 2. My apologies, a half plus 1 is 3 over 2. So right here, a half plus 1 is 3 over 2. A half plus 1 is 3 over 2. And we divide it back by 3 over 2. So that's all. Integration by substitution is so easy. So very easy. This just would be 3 over 2. So we have a half times, this is 1 over 3 over 2. 1 over 3 over 2 times a half. That's going to work out to be 1 over 2 multiplied by 1 divided by 3 over 2. So that's 1 over 3. So on the outside, I can put my 1 over 3 out here. 1 over 3. And this is really u to the 3 over 2. So that works out to be equal to, so it works out to be equal to 1 over 3. It works out to be 1 over 3. Let's do this easy question. So it's 1 over 3 times, now 3 over 2. When you're raising something to the 3 over 2 power, it means we cube it first and then square root it. So this is really 27 cube square rooted. That's what that means, 27 cube square rooted minus, plug in the 9 now, it's going to be 9 cube square rooted. All right, so that's that. Easy. So let's shell down this question now. So to finish shell down this question, it's going to be 1 over 3 times 27 cube square rooted is 27 cube square rooted. I'm getting, so put all this in your calculator. The square root of 27 cube square root of 27 cube minus the square root of 9 cube (4 square 16). I'm so stupid. 4 square 16. 16 plus 9 is 25. Oh gosh. I don't know. Oh gosh. My calculation is off. When you're doing these questions, make sure to use your calculator. That should be 25. This should be 25. And go straight down should be 25. Now plug those in now. We get 98. And now 1 over 3 times 98 is 98 over 3. And so this is how we do integration by substitution. Integration by substitution leads to integration by recognition. Easy, soft.